Hello, I'm going to go over the next section of the review for you, and I decided to do it this way because it seemed to really help a lot of the kids understand it, and then if they needed to, again, they can go back and relook at it. Okay, so look at this first part. What you're going to do is making sure that it is in the slope-intercept form, which is y equals mx plus b. If you forgot anything about this, the b is the starting point where you start on the y-axis, and the x is the slope or the rise over the run. So if you look at this first one, the b, or the beginning, is -7. So you start on this y-axis at -7. The slope is 1 over 1. So you go up 1, over 1, put a dot. Up 1, over 1, etc. until you make a line. So then you look right here at this next one. Okay, my beginning, or b, is 1. You go up to 1 on the y-axis, and you put a dot. My slope is -3 over 1. So you go down 3 over 1, down 3 over 1. And they end up meeting right here. The coordinates for these two lines are 2, -5. Okay, next part right over here, same thing. The difference for this first one is that it is not in slope-intercept form. So you have to take this 2x and move it to the other side so that you have just a y over here. So now you have y equals -2x minus 8. Again, you start at the b, the -8 on the y-intercept. The slope is -2, 1. You always go down, over. Once you run out of room, then you can do the opposite. So instead of dropping and running forward, you would rise and go back. Remember, you're like a little man, and you're always running forward, okay? Now you can rise and go up, or you can fall and go down, but you always run forward unless you run out of room on your graph, and then you have to do opposite both the rise and the run. Okay, and then on the next part, same thing. You want to make sure that it's in y equals mx plus b format. Once it is, which if you take this 3x and move it over here, you will have 4y equals positive 3x plus 12, and then you want to have just a y over here, so you divide everything by 4. That's how you get 3/4x, plus 3. So again, you start on the 3, you go up 3 over 4, or if you run out of room, you go down 3 back 4. And this right here is where they meet, at -4, 0. Okay, let's go on. 30 and 31, this is substitution. Remember, for substitution, you need to have either the x or the y isolated. And then whatever x or y is, you plug into the other equation. So here I have y equals -4x. Okay, well, I'm going to say in the bottom equation, everywhere there is a y, I'm going to put what? -4x. So then you can solve from there and get x is 3. Now that you know x is 3, you could plug that into either equation. The top one is actually going to be easier just because it's less numbers. And so then you will get that y equals -12. Okay, for 31, this one already shows you what y is. Well, y is x minus 4. So that means right here, everywhere there's a y, you're going to put x minus 4. Distribute, combine like terms, and 2x minus 3x is a -1x plus 12 equals 11. So then from there, you're going to subtract 12, and x is -1. Now this is where you need to remember, you can't have -x equals whatever, or even -y equals whatever. What you have to do is switch both of them. So what happens is x becomes 1. instead of the negative 1. Okay? Now you have x is 1. You can pick either equation to, push it into, and I'm going to pick the top one because it looks easier. So 1 minus 4 is negative 3. So now I have my x and y coordinates. That's where these two lines meet up. 32 and 33, this is where we started working with radicals and square roots. Basically, what you need to remember is you are bringing out pairs. What pairs do you see? Well, this is the same thing as 10 times u times v times v. Or you could say 2 times 5 times 2 times 5, okay, which is the same thing. You have a pair of 2's and a pair of 5's, which if you pull those out, 2 times 5 is 10. So it depends on if you go to, what you know, which is 10 times 10 is a pair and you can pull that out, or if you need to go further than that. So then you still have u left in the house. Over here, the perfect square of 64 is 8. So you can pull out the 8 and the m, and you are left with 8m root n. 34 and 35. You have a pair of 2's, pull that out, a pair of x's, pull that out, and what do you have left in the house? 5 and y. Remember, when you pull out the pairs, it only becomes 1 when it is out of the house. So here you have a pair of 5's. You pull that out. What do you have left? 2xy inside. 36 and 37. Well, I pulled this all the way down to prime. Or if you were super intelligent man, you would have known that that's really 2 times 9. 9 is a perfect square of 3. So you could have just pulled out the 3 automatically. So it just really depends on what kind of learner you are. Do you need to take it all the way down to prime? Or can you do a little bit at a time? Same thing with this, okay? You could have also said 15 times 10, which is 3 times 5 times 2 times 5. And you could see right there is your pair of 5's that you pull out. 38. Again, what is this? This is 8 times 2 times 5. Or you could have said 8 times 10 and then broke it down from there. Any way you go about it, you know that you have a pair of 2's, and that's going to give you 4 root 5. Right here, you have the same thing. 2 times 3 times 3, which is 18. Pair of 3's, pull it out. 40. Okay, I kind of have gotten to the point where I like to do this with the ELD method, where that you pull out right here. And the only reason why that I kind of have come accustomed to this and like it better for me, oops, that's supposed to be a 3, sorry about that, is because whenever I'm finished, I can see easier what my factorization is. To me, this is a little bit messy as far as to know which one to choose, but this is very straightforward. So I know I have a pair of 2's and a pair of 3's, which is 6, and then a root 7 left. 141, excuse me, is 147, gosh, I'm losing my mind, is 3 times 49, which is actually a pair of 7's. Pull that out. 42 and 43. Just going to give you a second to look over that because I have more than explained it. Okay, 44 is a little bit different because there is already an 8 here. Okay, so what that means is whatever you pull out, so here I pulled out a 10, right, because I have a pair of those. It would be just 10 root 10, but there is already an 8 out here. So I have to multiply what I pulled out, which is the 10, times whatever is out there, which will give you 80 root 10. Same thing here. I pulled out a pair of 2's. The 2 I pulled out, and the 2 that was already there. Those are multiplied together to give you 4, and then you have a root 3 left in the house. 46, same concept. 16 is a perfect square, so some of you just know, okay, that's 4, I'm going to pull that out. But if you didn't, it's 2 times 2 times 2 times 2. That would be 4, and there was already a 3 there that you pulled out, so you have 12 as your final answer. This right here, when you do the prime factorization, you have 2 times 3 times 7 times 7, which means you have a pair of 7s. That pulls out. You already had a 7. So now you have 49 root 6 left. 48, what is the difference between a number being squared and cubed? Well, I think that's pretty self-explanatory, but this again gets back to you knowing your written rationale. And that is not only that you can visually or mathematically show me, but that you can always also tell me. A number is squared if a number squared is that number times itself. A number cubed is that number 3 times, and this should say here, multiplied. Okay? So whenever you're given these explanations, especially on the exam or anything that you're doing with math and writing, you need to be as specific as possible, and then go back and check yourself. Okay, did I write this the way that I was supposed to? And so another example of that would be 49. What is pi in terms of a mathematical relationship between two things? This is not, oh, pi is 3.14. I know that. Okay, everybody, even a third grader knows what that is. Okay, pi is not apple or cherry. That's not what I'm talking about. What I'm talking about is pi, mathematical relationship. All circles have the same ratio, which means that if you take a circle's circumference around it, okay, and divide it by the diameter, which is going straight across, then you will get pi, or 3.1415, etc. Okay? So what I'm looking for here, and what you need to know, is all circles have the same ratio of circumference divided by diameter. It doesn't matter if it's the itty-bittiest circle or a huge circle. That's a horrible circle, but just pretend like it's not. Or that big circle that's outside on the field that's got the links in it. It doesn't matter. It's the same. All right, solving for x. Vertical angles are congruent. Remember we did this little z method where that we said, hey, these are equivalent, and then these are also equivalent. So vertical angles are congruent or equal to each other. So you're going to set them up equal to each other. X plus 7 equals, x plus 77 equals 70. Subtract 77. X is -7. Same thing here. These two are the same. Now, if you're confused and say, I don't know if I should make these equal to each other or equal to 180. First of all, you need to look. These are a little bit more difficult to tell because they look like they're very similar as far as their angles. But right here, you can tell this is an obtuse angle and this is an acute angle. So those two would equal 180. But this is acute and this is also acute. So if they're both acute or both obtuse, chances are they're equal to each other. If they're opposite, chances are they're equal to 180. 52 and 53, again, all you're doing here is just setting these equal to each other. So 21x plus 4 is equal to what? 130. And this is a great example for me to show you what I was talking about. This right here is an obtuse angle. Obtuse. So they are more than likely equal to each other. Just even if you don't know the rules about vertical angles and everything else, you can just look at those and tell. These are acute, So they are equal to each other.